Hello, welcome back. We're going to fly through questions 3 to 8. So that's the rest of the silver on the 2016 paper. So 87 take away 40 is the first one. So 87 take away 40 equals obviously the answer. Again, you're taking away from a whole here. So if the whole is 87, the way you need to look at it is if you have the whole of 87 and you take away 40, what's this answer here? Now, if you're confident counting backwards or forwards in tens, that's fine. Personally, I'd prefer to use the counters for a subtraction question. So the good thing about subtraction is you only ever start with one number here. So I've got 87, which is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 10 counters as we'd have in class. So just double check, 1, 2, 3, 4, 5, 6, 7, 8. And then we have 7 ones, 1, 2, 3, 4, 5, 6, 7. So these are all ones, or eyeballs as they look like with this pen. So 87, 1, 2, 3, 4, 5, 6, 7 ones. So a lot of people call them units. I like to call them ones because that's their value. Tens. Now you've got to remember that in a subtraction you only ever start with this amount. This is what's taken away. It's not a separate entity. It's not a separate number. So you're only taking from this, which the bar demonstrates anyway. So this is where your knowledge of tens comes into play really, because 40, if you know your tens, 4 tens make 40. And it's a case of, if you had the counters, you could move them away. Taking away 4 lots of 10. And your answer being 1, 2, 3, 4, 4 tens left. And 1, 2, 3, 4, 5, 6, 7 units. And some children might notice the pattern with the tens, that they could just take the tens from the tens column anyway and leave the units alone. So that is 87 take away 40. So for our next question, grab a white. So rub this out. Is 50 take away an unknown number equals 20. So I'm going to flip the board over for a second to let that dry. So 50 take away an unknown equals 20. Now, pattern sniffing is a really important part of maths, and some children might already notice the 5 and the 2, in which case they might be able to pattern sniff the answer anyway. It's just building on their knowledge of a bond of 2 and 3 making 5. However, in bar modelling form, the whole is going to be what you're taking away from. So this whole is 50. Again, I've mentioned in previous videos that I prefer putting 50 on the end and outside the box, purely for the fact that it replicates that number line from 0 to 50. But a lot of people just like demonstrating that the bar is 50, the whole is 50. It's up to you, whatever works for you. So 50 take away something. Now, you may not know, you may not have the knowledge that 20 is less than a half of 50. So if a child was to do this, it's not that much of a problem yet. It's still achievable, it's still solvable, because again, it's the two parts that are key in this. 20 is the answer when we take off this unknown. So what is this unknown? Well, again, if you've got knowledge of your tens, you can go back 2 tens to get to the answer, which is 30. Or similar to the last question where we had 1, 2, 3, 4, 5 10 counters. And then you can visualize how many would I need to take away to be left with 20. Well, if I need to be left with 20, 1, 2, 3, I would need to take 3 tens away. So the answer would be 30. So that's just another example of how you could solve that. But really, I'd be looking at the recognition of tens and the pattern sniffing on that occasion. So if we go to, before we do, I'm just going to pop those answers onto the sheet. So number 3, 87 take away 40 is 47, and 50 take away, I'm not really going to have room to write it in the box, so I will put it there. Now 8 lots of 10 is question 5, and again that's just knowledge in steps of 10, but again there is an element of pattern sniffing to this. 8 lots of 10. The board's having a bit of trouble now. So if I've got 8 lots of 10, I could look at the pattern of 8 and 1. 8 ones are 8. If we're talking about tens, the pattern emerging from the 8 lots of 1, so the 8 lots of 10 is 80. Similarly, you can go up in tens 8 times, 10, 20, 30, 40, and so on to get to 80. So that is all based on knowledge or steps of 10. With regards to how that would work with a bar, well, you've got your whole, which you don't know, and it's a case of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, my mistake. So 8 lots of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean, well, I could make that work because again, multiplication is commutative. So I could fill all of these 10 boxes with 8s. So that is correct in a way. But as it's written 8 lots of 10 or 8 groups of 10, this is how the bar would look. So you can see where that knowledge of multiplication is going to give you shortcuts rather than repeated addition all the time. Hence why this symbol would have been founded historically instead of having to add multiple times. So 8 lots of 10, 80. And the bar will show that, demonstrate that as you count 10, 20, 30, 40, 50, 60, 70, 80. So if we go to our sheet, we can pop that on. Now this one, I'm not going to use the board. 2 times 0, as the Americans call it, or naught. It's not an O, O's a letter. So 2 lots of naught. I prefer to call naught nothing, or a nothingness. It's not a number, it's a concept, and it's a concept of having nothing. And if I was to ask a child, if I've got nothing in my hand and I've got 2 lots of nothing, how much do I have? And however many lots of nothing you can think of, you're still going to end up with nothing. So if I've got 2 children, they both bring nothing to my party, I end up with nothing. So this one, if we can get across the idea that naught is a nothingness or an emptiness, probably the most important symbol in mathematics, arguably, then children will gradually start to realize that 0 is a concept or an idea of nothingness, and however many times you multiply it, you're still going to have nothing. That's a tricky one. I've tried in year 6, that concept can be quite tricky as well, so in year 2 it'll take some thinking. 3 lots of 3, again, knowledge of tables. I'm going to release a video on help with tables called Breakfast Maths, which worked really well with my children. I hope it works well for you guys as well. 3 lots of 3. So again, it's this idea of multiplication having started as repeated adding. So I'm hoping this board's dry by now because it's causing mayhem with my pen. Poor preparation, I've run out of tissue. So 3 lots of 3. You have 3 lots of 3, like so. And then the whole, if you add them all up, is 9. So 3, add 3, add 3 is 9. You can draw it as a number line. 3, add 3 more equals 9. You can also do 3 lots of 3 as an array of counters as well. And the reason I like these is because it shows you that 9 is actually a square number with 3 by 3. So a couple of ways to do that one, but essentially good knowledge of tables is helpful for these sorts of questions. And last but not least, 12 divided by 2. Again, it depends on how you look at it really, because if you have 12 divided into 2 groups or 12 divided into 2s, I prefer to use the language, how many 2s are there in 12? But you could do it either way. So one way you can do it is 12 divided into 2 groups. Another way you can look at it is how many 2s are there in 12? In which case it would look something like this. So 1, 2, 3, 4, 5, 6. So there are 6 2s in 12. Or if you share 12 equally into 2 groups, you would see 6. Now this is where the arrays come in and the counters as well, because if I were to do this question as an array, you'll see something interesting develop. And that is, if I have 12 and I start creating 12 by using groups of 2, 1, 2, another group of 2, that's 4, 6, 8, 10, 12. And you'll see that this side is 2 counters tall. In this area here we have 12 counters, and across the top you have 1, 2, 3, 4, 5, 6 rows of 6. And if you strip this back to the bare essentials, or just to numbers or numerals, you'll see that this is the early formation of the bus stop or written method of division. So this one is about knowledge of equal groups and sharing equally, division, and some knowledge of tables and 2s. So the answer for this one is, how many 2s are there in 12? Or if I were to share 12 into 2 equal groups, either way my answer is going to be 6. And as I said earlier, we'll put up a post later on with breakfast maths, which is really good for times table knowledge. And we'll probably start with the 2 times table anyway when we pop that up. So there you go, that's the silver level completed of the 2016 paper. I hope this helps. Feel free to comment or like or dislike if it's no good. Hopefully it's the former, not the latter. Stay safe everyone, I hope you're all doing well, and hope to see you very, very soon. Keep working hard and try not to forget all of the amazing stuff you've learnt so far this year. Thanks a lot. Bye-bye.